So what we're going to do today, guys, is take a look at division. We looked at multiplication last week, Wednesday. We looked at rules for negative and zero exponents, which really didn't have a operation that was done. It was just, what do we do if we see a zero exponent? What do we do if we see a negative? But now we're going to jump into division and take a look at what that does. So what we want to be able to do is take that first problem here and do it without a calculator.
Oh, we did it before.
You should have, yeah. All of these rules are things you guys should have seen last year, so we're kind of moving through them, make sure you guys have those again. So when we take a look at what we have here, I can't do 5 to the 4th in my head very accurately and keep track of those, much less divide it by 4 to the 3rd. But what I do know is that 4 to the 5th means I have 4 times 4 times 4 times 4, 5 fours, correct? And so then my 4 to the 3rd means I have 3 fours. So let's get those written out. And some of you need to realize, ladies and gentlemen, that the more you write down, the more useful your notes are. I don't write this down because I need it. I write it down because you need it. I've also had some students say to me, well, it makes more sense when you're explaining it. Well, when I look at their notes, ladies and gentlemen, they don't have any of my explanation written down. Duh, that makes sense. Okay, guys? You've got to write down what I wrote down. You're not going to be able to remember that we wrote out these fours a day later. Well, what I want to keep in mind for you, ladies and gentlemen, is this is really just a fraction. And when we simplify fractions, we divide the numerator and denominator by the same values. So we can divide 4 by 4. What is 4 divided by 4? 1. And we can divide again, because we have 4 divided by 4, and that's a 1. And then we can do 4 divided by 4 a third time, correct? And that gives me 1. Well, now if I look at this, ladies and gentlemen, I really just have 4 times 4, correct?
Yeah.
And can I do that rather easily in my head right now?
Yes.
Can most of you do 4 times 4 rather easily in your head right now?
Mm-hmm.
Yeah. And so we get 16. So something that was going to take quite a bit of brain power now comes down to the fact that we can cancel things out if we have the same base in both the numerator and denominator. So if you guys take a look at our first rule here, that if we want to divide powers that have the same base, you simply have to subtract the exponents. So let's take a look at what or how that applies to what we have here. What is 5 minus 3? 2. And how many 4s did I have left? 2. 4. And so the reason that we use that subtraction rule, ladies and gentlemen, is because we're not combining our bases together anymore. We are actually going to be canceling them out. And so one of the ways that I've explained this in the past is division is the opposite of multiplication, correct?
Yeah.
And so doesn't it make sense that we're going to use the opposite rule with division? So if we add in multiplication, we're going to subtract with our division rule. Okay? So let's take a look at what these look like a little bit more closely, and then go through our examples. So here's what it looks like kind of in rule form, that if I have a to m divided by a to n, then I'm going to simply subtract m minus n. So if we take a look at this example, we've got 3 to the 7th divided by 3 to the 5th. That's going to be 3 to the 2nd power. Now keep in mind, ladies and gentlemen, I'm going to want you to then simplify that out. So you're not grabbing your calculator, ladies and gentlemen, until the very end of the problem. I had some people in second hour that were multiplying things out. You should not be using your calculator until this very end. And even then, do I need to use my calculator?
Not really.
Get 9. 2.
So we're just subtract between 7 and 5?
Yeah, because you're just canceling out 3's. You're just, and is this what it said here? Did it say to subtract the exponents? Yep. We have to make sure that it's the same base, so these both have to be 3's. If one is a 3 and one's a 4, I can't subtract their exponents. But as long as these are both 3's, they're both x's, we can do that. All right, so ladies and gentlemen, let's take a look at our second rule that we have here. If I have the power of a quotient, so that means I have a fraction, I have division in parentheses, what I'm going to do then is raise or apply the power to each term inside those parentheses. So if I have a over b, if I have a numerator and a denominator, both the numerator and the denominator get raised to that power. So this is going to be a to the m and b to the m. We saw that with our multiplication rule, guys, where everything inside the parentheses got the power. We just need to keep that in mind for division, that we do that to both the numerator and the denominator. So if we take a look at this example, this is going to be 4 to the third divided by 5 to the third. Now here we may have to start getting our calculators out. Fortunately, I know this is 64 and this is 125. The question that was asked second hour is, do you want us to simplify it? Yes, I want you to now check, does 64 divided by 125 simplify at all? Now those of you that know some things about your factors, if 4 and 5 do not simplify, then 64 and 125 won't. But double check that in your calculator. Take 64 divided by 125, turn it back into a fraction, and it should give you 64 over 125. So my work there is done. But if you get 10 over 15, ladies and gentlemen, does 10 over 15 simplify? Yeah, so you're just going to be checking those. 10. 64 divided by 125. Math. And then it should say arrow fraction. Enter. Enter. Math. Enter. Beautiful. All right. So ladies and gentlemen, let's work through some example problems together. The first one, we have this negative 3 over y raised to the third power. I don't like my negatives being out in front, ladies and gentlemen. I want to apply it to some, I want to make sure it's either in the numerator or denominator. So I'm going to take this negative here and I'm just going to move it up with the 3. I like having it with some number. Otherwise, we tend to forget about it. That negative never actually gets raised to the power, and it does need to be. So this 3 exponent is going to get raised to both the numerator and the denominator. So this is going to be negative 3 to the third over y to the third. And that's all you're doing, ladies and gentlemen. If I have anything that can simplify, then I want to do that. And I see a couple of you guys grabbing your calculators, so you're probably typing in negative 3 to the third, correct? Stop and think, guys, before you start hitting too many buttons. Should my answer be positive or negative here?
Negative.
Why?
Because there's one negative and one positive. It's going to be a positive.
How many negative 3s do we have? 3 of them, and so because we have 3 negatives, it's going to stay a negative answer. If it was negative 3 to the fourth, it would be positive because we have an even number of them. So make sure your calculator is giving you negative 27. The safest way to do that, ladies and gentlemen, is to put your negatives in parentheses. So that negative 3 should be in parentheses before you raise it to the power. Y to the third doesn't have anything that can change there, and so there's my final answer. Pretty good so far? Yeah, this power has to go to both the numerator and denominator. That was the rule that we just had here. A had to be raised to the m power, and B had to be raised to the m power. All right, let's take a look at the next one, ladies and gentlemen. This is my favorite lesson in this chapter because now I get to start combining rules from 8.1, 8.2, and the new rules from 8.3. So you guys have to keep in mind that I have to simplify my numerator. How many 9s do I have in that numerator?
4. Oh.
How am I getting 6?
Add
4 with the first, 2 with the second, so I'm combining those together. So this multiplication uses that adding rule, right guys? I still have 9 to the 7th in the denominator. There's a couple of different ways to do this problem, ladies and gentlemen. I'm going to model them both for you. This is my favorite way to do the problem. I always ask my students, where do you have more at? So these are both 9s, correct? Where do I have more 9s at? In the denominator. How many more 9s do I have in my denominator? 1. So that would be 9 to the first power. But I have to have something in my numerator. What am I going to have to put up there, ladies and gentlemen?
1. What if negative 1?
Why negative 1? Thank you, Tim. You're leading me into the second way of doing the problem. The second way of doing the problem, ladies and gentlemen, is to subtract those exponents like the rule says. So what is 6 minus 7?
Negative 1.
And what is 9 to the negative 1 going to have to be rewritten as? 1 over 9. So do both methods get me to the same final answer? I like to avoid this, ladies and gentlemen, because I don't like having negative exponents. Okay? But if I look where I have the most at, I know that's where the 9 or where my x is going to end up at. All right, here we go. We have 7 over 4 to the negative 3. We saw a little bit of this yesterday, ladies and gentlemen, but now we can actually use a better rule. I'm going to take that negative 3 and apply it to everything inside of there. So I have 7 to the negative third over 4 to the negative third. Once you get rid of those parentheses, we're now just using those negative exponent rules that we had in 8.2. So if it's a negative exponent, it needs to
be split.
Beautiful. This negative is going to move down. This one is going to have to move up. So this becomes 4 to the third over 7 to the third. So I'm going to get rid of that exponent on the outside. I'm going to apply it to everything on the inside, then start moving my negatives around. 4 to the third is 64. 7 to the third, I think, was like
343.
Thank you. So far, so good, ladies and gentlemen? All right. I would go and try 64 divided by 343 just to be certain it doesn't simplify. But because I know 4 and 7 do not simplify, I know 64 and 343 are not going to. All right, ladies and gentlemen, how many of you love fractions in 4th and 5th and 6th and 7th grade? I did. They're the best. I like fractions, ladies and gentlemen. The thing I like about multiplying fractions is that it's pretty easy. I'm just going to multiply straight across. Numerator times numerator, denominator times denominator. So if I were to cover up this denominator, ladies and gentlemen, does this just look like some of the problems that we were doing in lesson 8.1? Yeah. So basically, all a fraction does is give me the opportunity to give you 2 problems from lesson 8.1. So I'm going to multiply across. What's 2 times 9?
18.
How many x's do I have total there?
2, 3.
How am I getting 3?
Because 1x plus 2x.
Good job. 2 x's and 1 x is 3 x's. How many y's do I have?
3, 6.
In the numerator.
3.
1 plus 2 is 3. You cannot, notice I have an arrow over the numerator, and then I have an arrow over the denominator. Those are 2 separate problems. I'm now going to go to my denominator and multiply my denominator. The 3 is the only coefficient there, so it just stays 3. It's not really getting multiplied by anything. I only have the 1x, so it just stays x, and I only have the 1y factor, so it stays y to the 4. Now what we've done, ladies and gentlemen, is turn this into a division problem. Okay? What you need to keep in mind is that it's exactly what it is. It's a division problem. So these coefficients, ladies and gentlemen, follow the rules that you learned back in 3rd and 4th grade. 18 over 3 is divided into the number 6. Those are not exponents. They do not get subtracted. Those are what we call coefficients, which is why your math vocabulary is so important. And so we do division with those. But now I'm looking at my x's. Where do I have more x's at?
Top.
And how many more do I have?
2.
I need to look at my y's here. How many, where do I have more y's at?
Bottom.
So I'm going to have to make it a fraction by drawing a fraction line. And how many more y's do I have? 1. Do I need to put y to the first here, guys, or is the y going to be enough to tell me that I have 1 y?
The y's enough.
Any questions on those 2 examples? Riley?
Why is the word bottom?
Because we've got 3 y's in the numerator, correct? I have 4 y's in the denominator. Where do you have more y's at? And so if you cancel those out, like we did that first example, that y isn't going to be left in the numerator, it's going to be left in the denominator. Okay, does that help a little bit? All right. One last example, then you guys get to get started.
Yes.
All right. This exponent needs to be applied to everything. And when I say everything, ladies and gentlemen, I mean everything. So in that numerator, it needs to be 2 to the 4th and x to the 4th. It's not just what's closest to the exponent, it's that entire numerator. And then my denominator needs to have that, but what is this y going to become?
44. 8. Why 8?
Good job. If you need to, ladies and gentlemen, write it out 4 times. It's easier to write it out when it's positive. It makes it much more difficult when it's negative. Okay? But we're going to multiply our exponents together when we have that one base. Now when I look at this, ladies and gentlemen, 2 to the 4th we're going to call 16. There's only one x, it stays x to the 4th. There's only one y, it stays y to the 8th. Because everything was positive here, nothing has to move.
Yes.
That's our final answer.
Do you want us to
All right.
circle final answer?
I should be able to find where your final answer is. If that means you have too much work crammed together and should circle it for me, then please do that. If it's obvious where it's at, I don't really need that. Okay? Ladies and gentlemen, there is a typo on your notes. It says page 446. It should be page 466. Or did I change that on your notes, guys? Does it say 466 on the notes?
It says 446.
446 on the notes? Okay. On the agenda, it says 466. If you look at the notes, I believe it says 446. You're doing 21 through 30. You're doing the multiples of 3. You're doing 31 through 50. It doesn't say anything after it, ladies and gentlemen, so guess what that implies?
All of them. Beautiful.
So, with about 15 minutes of class left, you should be able to get quite a bit done. Ladies and gentlemen, let's get to work.
I do have 90.